Under the hood of your car, tucked somewhere between the air filter box and the throttle body, is a component no bigger than a pack of playing cards. It doesn't look like much, a plastic housing with a few wires coming out of it. But this little sensor is the guardian of one of your engine's most critical calculations: airflow. This is the mass airflow sensor, or MAF. Its job is simple but vital. It measures the exact volume and density of air entering the engine and sends this data to the car's computer, the ECU. The ECU uses this number, more than almost any other, to calculate the perfect amount of fuel to inject. When the MAF is clean and working correctly, your engine runs smoothly, efficiently, and powerfully. But when it gets dirty, coated in the invisible grime of oil vapors, dust, and carbon, it starts to lie. It sends bad data. The ECU then miscalculates the fuel, leading to a cascade of problems: poor fuel economy, rough idle hesitation during acceleration, and even a lit check engine light. You might be told you need a new MAF sensor, which can cost hundreds of dollars. But very often, the solution isn't replacement. It's a careful, proper cleaning. Today, we're going to walk through the right way to clean a mass airflow sensor at home. This isn't about hacking your car. It's about basic, intelligent maintenance that can restore performance and save you a significant amount of money. First, you must understand what you're dealing with. Inside that plastic housing are one or two very delicate sensing elements. Most modern cars use a hot wire or hot film sensor. Imagine an incredibly fine wire or a tiny ceramic plate, thinner than a human hair. The ECU sends a current through this element, heating it to a specific temperature above the incoming air. As air flows over it, it cools the element. The ECU measures how much extra current is needed to keep the element at its target temperature. More current means more air is flowing. This measurement is exquisitely sensitive. Now, imagine that fragile hot wire getting coated with a thin film of oil from the crankcase ventilation system, or dust that sneaks past the air filter. This gunk acts as an insulator, like a tiny blanket. It prevents the air from cooling the wire properly. The sensor now reads less airflow than is actually coming in. The ECU, trusting this false data, injects less fuel. The result is a lean condition: too much air, not enough fuel, which causes misfires, hesitation, and lack of power. Your car is essentially being strangled by dirt. Before you declare a dirty MAF the culprit, you need some symptoms. Watch for these signs. Poor fuel economy is a big one. You're burning more gas because the engine is running inefficiently. A rough or unstable idle, especially when the car is in gear but stopped. The engine might surge up and down. Hesitation or stumbling during acceleration, particularly when you press the gas pedal from a stop. The car might feel sluggish, like it's being held back. A check engine light with codes like P0101, MAF performance, or P0171, System 2 lean, is a strong indicator. However, these symptoms can also point to other issues like vacuum leaks or bad oxygen sensors. A dirty MAF is a common and often overlooked cause. If you suspect a dirty MAF, cleaning it is a logical first step before costly diagnostics or parts replacement. Here's what you'll need for the job, and crucially, what you must avoid. You will need a MAF sensor cleaner. This is non-negotiable. You must use a cleaner specifically formulated for mass airflow sensors. Brands like CRC or STP make it. It is an electrical contact cleaner that leaves zero residue. It evaporates completely and won't damage the delicate sensing elements. This is the only cleaner you should use. You will also need a clean, soft-bristled brush, like a new, small paintbrush or a dedicated electronics brush. It must be clean and soft. Safety glasses and gloves are important as the cleaner is a strong solvent. Finally, have basic hand tools, usually just a Phillips head or Torx screwdriver to remove the sensor from its housing. What you must never use includes carburetor cleaner, brake cleaner, throttle body cleaner, WD-40, compressed air from a can or compressor, and Q-tips or cotton swabs, as fibers can get stuck on the hot wire. These are all far too harsh, leave residues, or can physically blast and destroy the fragile sensor element. Using the wrong cleaner is a guaranteed way to turn a dirty but functional sensor into a completely dead one. The first step is safety and preparation. Park on a level surface, set the parking brake, and let the engine cool completely. Disconnect the negative terminal of your car battery. This is a critical safety step. It prevents any electrical shorts or accidental signals from being sent to the ECU while the sensor is unplugged. It also resets the ECU's adaptive memory, allowing it to relearn with a clean sensor. Next, locate and remove the MAF sensor. Open the hood and find the air intake assembly. It's the large plastic tube running from the air filter box to the engine. The MAF sensor will be housed in a segment of this tube. Unplug the electrical connector. There's usually a small tab you press to release it. Then, using the appropriate screwdriver, remove the 2 or 4 screws that hold the sensor into the housing. Carefully pull the sensor out. Avoid touching the sensing elements inside. Now, inspect and perform an initial clean. Hold the sensor up to the light. Look inside at the small elements. You will likely see a dull gray or black film on them. Take your dedicated MAF sensor cleaner. Spray liberally from about 6 to 8 inches away, directly onto the sensing elements. Do not scrub yet. Let the solvent soak and dissolve the grime for about 30 seconds. You'll see it dripping dirty. After the initial soak, use your clean, soft, bristled brush. Gently flick the brush across the sensing elements. Do not press down or scrub. The goal is to help dislodge softened debris, not to sand the element. Spray with cleaner again to wash the loosened dirt away. Repeat this soak and flick process 3 to 4 times until the elements look shiny and metallic again. Then, perform the final rinse and dry. Give the sensor one last thorough spray with the cleaner, ensuring all surfaces are wet. Then, set the sensor aside in a clean, dry place. Let it air dry completely for at least 30 minutes or until you are certain no liquid remains. Do not use compressed air to dry it. Do not reinstall it wet. Once bone dry, carefully insert the sensor back into its housing in the intake tube. Retighten the screws snugly, but do not over-tighten. Reconnect the electrical connector until it clicks. Finally, reconnect the negative battery terminal. Now for the relearn drive. Start the car. The idle may be high or erratic for the first minute. This is normal as the ECU relearns the new, clean airflow data. Take the car for a 15 to 20 minute drive. Drive normally at first, then include some gentle acceleration and a period of steady highway cruising. This allows the ECU to recalibrate its fuel trims across different driving conditions. If you've done everything correctly, you should notice an immediate improvement. The idle should smooth out, throttle response should be crisper, and over the next few tankfuls, your fuel economy should recover. You've just performed a key piece of preventative maintenance that keeps your engine breathing right. It's a simple task with a powerful payoff. A smoother running car and money kept firmly in your pocket. Remember, the right way is the gentle way. The right cleaner, the right touch, and the right patience. A clean mass airflow sensor is more than just a maintenance task. It represents a fundamental understanding of your engine's language. The MAF is the primary translator between the physical world of air and fuel and the digital brain of the engine control unit. When that translation gets fuzzy, the entire conversation breaks down. But to truly master this simple repair, you need to think like the ECU for a moment. The air entering your engine is never constant. It changes with altitude, temperature, humidity, and throttle position. The MAF's genius is that it measures mass, not just volume. A hot, thin air at high altitude has less oxygen per cubic foot than cool, dense air at sea level. The hot wire sensor accounts for this because the cooling effect is based on the density of the air molecules hitting it. When dirt insulates the wire, it's not just reading low. It's losing its ability to sense these subtle density changes. The ECU compensates with its other sensors, primarily the upstream oxygen sensor, but it's always playing catch-up, leading to the drivability issues you feel. Cleaning the MAF restores its precision, allowing the ECU to return to its finely tuned, proactive fuel calculations instead of clumsy, reactive corrections. Let's delve deeper into the why behind the strict rules. The prohibition against Q-tips and compressed air isn't arbitrary paranoia. The sensing element, whether a wire or film, is microscopically thin and under tension. A cotton fiber from a swab can snag on a microscopic imperfection and, with the slightest pressure, break the element. At that point, the sensor is irrevocably dead. No amount of cleaning will fix a physical break. Compressed air, even from a small can blast the element with enough force to snap it, or at the very least, dislodge its precise calibration within the housing. The ban on other cleaners is a chemical reality. Carburetors and brake cleaners are designed to dissolve heavy, tarry deposits. They contain powerful solvents and lubricants that leave behind a residue as they evaporate. This residue then becomes the new contaminant on the MAF, often worse than the original dirt. Throttle body cleaner frequently contains oils or other additives to lubricate the throttle plate spindle. These oils will coat your MAF element instantly. MAF sensor cleaner is uniquely formulated with ultra-pure medical-grade solvents that evaporate at room temperature without a trace, leaving the sensor element in a chemically virgin state. The process of letting the sensor dry completely is another critical step that can't be rushed. If you reinstall the sensor, while even a minuscule amount of cleaner is lingering in the housing or on the connectors, you risk two failures. First, when you start the engine, the sudden rush of air can pull residual solvent into the intake stream and onto the hot wire, potentially causing a thermal shock or uneven evaporation that leaves a spotty residue. Second, and more subtly, leftover solvent in the electrical connector can cause a short or create a path of high resistance, corrupting the voltage signal the MAF sends to the ECU. This can create new, confusing drivability problems that weren't there before you fixed it. Patience is the final, essential tool in your kit. The 30-minute dry time is a minimum. If the humidity is high, give it an hour. The goal is absolute certainty. What about after the cleaning? If the problems persist, your diagnostic journey isn't over. It simply confirms the issue lies elsewhere. A persistent rough idle could be a vacuum leak in one of the many hoses connected to the intake manifold. This unmetered air sneaks in after the MAF sensor, tricking the ECU just like a dirty MAF would. Hesitation could be a failing fuel pump or clogged fuel filter. A check engine light that returns could point to a failing oxygen sensor or a leak in the exhaust system before the sensor. The beauty of starting with a MAF cleaning is that it's the lowest cost, highest probability fix. By eliminating it as the cause, you've narrowed the field and saved money before delving into more complex diagnostics. It's the cornerstone of logical troubleshooting. Furthermore, consider the preventative aspect. A dirty MAF is often a symptom of another minor issue. The primary source of oil film is the positive crankcase ventilation system, which routes blow-by gases from the engine crankcase back into the intake to be burned. If your engine is worn or the PCV valve is clogged, it can send excessive oil vapor toward the MAF. A poorly sealing or low-quality air filter can allow more dust to pass. By cleaning the MAF, you might also be prompted to check and replace your air filter or inspect the PCV valve, performing a small package of maintenance that protects your engine's breathing system as a whole. In the broader context of car ownership, learning to clean your MAF sensor is an empowering act. It demystifies a complex machine. It teaches you to listen to your car, to interpret the subtle language of a rough idle or a hesitant throttle as a specific solvable problem rather than an ominous, expensive mystery. It connects you to the physical reality of how your car works. Air in, fuel mixed, explosion controlled. This knowledge builds confidence. The next time a warning light glows or a strange behavior emerges, you have a foundation. You start with the simple, free checks before fearing the worst. You become an active participant in your vehicle's health, not just a passenger to the repair shop. In the end, the humble mass airflow sensor is a gatekeeper. Its condition dictates the efficiency, power, and cleanliness of your engine's combustion. A $10 can of specialized cleaner and 30 minutes of careful, respectful work can restore hundreds of dollars in performance and fuel economy. It reaffirms a timeless mechanics principle. Always start with the simplest explanation. Often the problem isn't a broken part, but a dirty one. By treating this precise instrument with the care it demands, using the right chemicals, the gentle touch, and the necessary patience, you don't just clean a sensor. You restore a critical line of communication, you reclaim lost power and efficiency, and you prove that the most effective repairs are often the simplest, provided they are done correctly. Thanks for watching, and remember, The most powerful tool in your garage isn't always a wrench. Sometimes it's the right piece of knowledge. Happy driving, and we'll see you in the next video.